Okay, so this is the next one we're going to try to prove, and it states the angle subtended by an arc at the center of the circle is twice that which it subtends on any part of the circumference. Now you see this word subtended simply means formed. The angle formed by an arc at the center of the circle is twice that which it forms on any part of the circumference. This is a diagram that represents this statement. Now it is basically saying that this arc, okay, as you can see, these two lines spring from this arc and it forms an angle here at the center of the circle. Now it is saying that since this angle here on the circumference still springs from this arc, if you multiply the angle here, you're going to get the exact same thing as the angle here. The angle formed by the arc at the center of the circle is twice that which it forms at the circumference. For instance, if this is 150 degrees, let's say this angle here is 150 degrees, it means that this is going to be 75 degrees. So if I multiply the one it forms at the circumference by 2, I'm going to get the one it forms at the center. If this was 100 degrees, it means this is going to be 50. Okay, so that is what we're going to try to prove. We're going to try to prove that once you multiply this angle formed at the circumference, it will give you that which it forms at the center. And this is it. It must all spring from the same arc. Okay, whether it's a chord that was drawn here, as long as it's coming from an arc, that is what we're going to try to prove. Okay, so let's get to it. Now, just before we prove it, remember the theorem says that on any other part of the circumference. So imagine you had a circle like this, and this angle here was formed at the center, okay? And you had this. So it means as it subtends an angle at the center, it also subtends an angle at the circumference. Whether it was here, or whether it was here, or here. All right, all of this means on any other part of the circumference. So the rule still applies. Whichever direction on the circumference that the other angle is subtended. So let us prove it now. Now, as usual, before we get to our proof, we need to write down what is given. So looking at this diagram, what do you think we are given? Well, we can start with saying that we're given a circle ATB, all right? So, given a circle ATB, and then what are we required to prove? So we are required to prove that angle AOB, remember the angle here is directly pointing to the one at the center. So angle AOB simply means the angle at O is equals to times angle ATB. ATB. So that's what we're required to prove. That whatever we get here, if we multiply the one we get here by 2, it's going to give us the same angle as this. And do we need to make any construction? Yes, we need to make a construction. So construction. Now look at this diagram. What construction are we going to make that will help us get to our proof easily? So I am going to divide this into 2. I'm just going to take it, I'm going to produce a line that will cut this center into 2 and lead it to a point D. It doesn't matter where the d stops. What just matters is that I have divided this into two parts, and we're going to see how this is going to help our proof. So we are producing a line, and that line is TO. We produced it to D. So we produce a line TO to D. All right. Now, this is a crucial step, the proof. All right. Now, this line I drew from T down to D has divided this diagram into two parts, and it has divided it into two triangles. Now, this is a triangle and this is a triangle. So how does it help? First, if this is the center of the circle, and I drew a line from this point and took it to the circumference, it means I have produced what? A radius. So this line is a radius, and from here down to this point is another radius. So what does that tell us about this triangle? If I have this as a radius and this as a radius, which are obviously the same in length, what does that tell us about this triangle? Well, it tells us that it is an isosceles triangle because two sides are equal. So in an isosceles triangle, if two sides are equal, what happens to the base angles? They are also equal. So it means that this angle here and this angle here are both equal. So how do I write this down in my proof? I'm going to come here and say, first of all, line TO equals line AO, and I'll give the reason by the side. So I'm going to say line TO equals line AO. And what's the reason? Both of them are radii. So both of them are radii. This is a radius, TO, and AO is also a radius. Now the next step is, so I'm just going to call one of these base angles x. So if this base angle here is x, it means this is also x, because in an isosceles triangle, the base angles are equal, all right? So I'm just going to come here and write down, therefore, x equals x, all right? And what does that mean? Since I've indicated that in my diagram, I'm going to write base angles of an isosceles triangle. Now the next step. So why did I produce a line and stretch it till it got to D? Why did it cross the diagram? Well, we're going to get why I did that. Do you remember a property of triangles when it comes to interior and exterior? So there's a rule that says that if you add, this is a triangle, if you add the opposite sides of a triangle, it will give you the exterior angle. So if this is a triangle, these are the opposite sides. When I add them, it gives me what is in the exterior. That is a rule in mathematics, triangles, all right? Now in this case, the opposite sides in this triangle, the sides opposite the exterior angle is this x and this x. So which means that if I say x plus x, it gives me 2x. And this 2x is the exterior angle right outside. And what's the reason? Sum of opposite interior angles equals the exterior angle. So in a triangle, when you add the opposite sides, it gives you the exterior angle. Now what's the next step? Everything I've done for this first triangle is the exact same thing for the other one. So let us call these two base angles here, let's call it y on the other angle, all right? And that definitely means that y plus y gives us 2y outside, because these are the two opposite interior angles, and the sum gives us the exterior. So if this is 2x, this is also 2y. So I'm going to write also y plus y equals 2y for the same reason. So everything I'm writing down in my proof, I have noted it in my diagram. So if an examiner is trying to give me marks, he sees that what I have in my proof is already in my diagram. Now, what did we just bring out? Remember, we're trying to prove that the angle formed by this arc at the center of the circle, that is this angle, is 2 times that which it forms at the circumference. So what it means now is I'm going to go back to what I wrote here to prove angle AOB equals 2 angle ATB. So have I been able to bring out my angle AOB? Now note that angle AOB equals x plus y. And that is obvious because this is the angle ATB, angle ATB equals x plus y, and that's angle ATB, right? ATB equals x plus y. And then what of angle AOB? Also, angle AOB equals 2x plus 2y. So what does that mean? Now this means that angle AOB, which is x plus y, equals 2 angle ATB, which is 2x plus 2y, and that is our proof. X plus y equals 2, open the bracket, x plus y. As simple as that. This proves this theorem.